Hey guys, so today we are going to be covering the topic of counting. So this is the first video in my statistics series. Now, what this video is going to go over is the multiplication principle, factorials, permutations, combinations, Pascal's triangle, and binomial expansion. All right, the multiplication principle. So what the multiplication principle is getting at is that if there are A ways that an independent event can occur and B ways that another independent event can occur, there are A multiplied by B ways of doing these things. So let's have a look at this tree. Consider you have A and you have B. And now let's consider that each of these events can happen in three ways. So A can occur in three ways and B can occur in three ways. Well, that means that there are 6 ways that both of these events could occur. All right. A factorial of n, denoted n factorial with the exclamation mark, is the product of all positive integers less than or equal to n. So this right here is the positive integers symbol, that z, you're going to see that a lot. So n factorial equals, this is what n factorial means. N factorial means n multiplied by n subtract 1, multiplied by n subtract 2, multiplied by blah, 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 multiplied by 2, multiplied by 1. So it goes all the way back. Let's just, before we move on, imagine 3 factorial. What would that be? That would be 3 times 2 times 1. You get it? 5 factorial. 5 times 4 times 3 times 2 times 1. It's just all the integers up until n. A permutation is a set of n objects in a set ordering where r objects are chosen. This is notated or denoted PNR or NPR, and it's defined using the equation NPR equals n factorial over n take r factorial. So this is, imagine you've got a set of things. You've got 5 days of the week and it has to be in some set order. So the order matters. So what you're saying is that Monday, Tuesday, Wednesday, Thursday, Friday, that's one order. Tuesday, Monday, Wednesday, Thursday, Friday, that's another order. So those would be 2 separate orders, right? So that would be 2, and then you could have all the other orders. So the order matters. All right. But a combination is where the order does not matter. And so this is notated CNR or NCR or NR in brackets. And this is the most common one, this one in brackets, because combinations are going to be used a lot. So they've got this special way of denoting them. And this is applied using the equation NCR equals n factorial over r factorial, n take r factorial. Now, my definitions have been a little risky. You might not have understood. That's okay. I'm going to give you some examples that will cement it in your head. So don't worry if you don't understand it yet. Let's move on. So 5 people are sorted between 2 teams, shirts and skins. First, we're going to go over combinations. So in combinations, order doesn't matter. So we're just looking at the number of configurations. So that's, let's say we've got 5 people, put 3 people in one team, 2 people in another. Let's say Charlie, Mick, Steve, Ryan, Josh. How many configurations are there? We could have Josh, Mick, Charlie in one, Ryan, etc. in the other. Keep jumbling it up. How many are possible? The way we work is n. N is the number of people, 5, and r is number of teams, 2. So we've got 5 people sorted into 2 teams, n sorted into r. Chuck it in your calculator, 10. Permutations. So in permutations, the order matters. So we've got each team has a team leader and each subsequent player is given a position in the team such as goalie and attacker. Of all the possible combinations, How many are there? So got n people sorted into we've got 5 people sorted into 2 teams, but the order matters. Because we've got the goalie, we've got the attacker, we could have Josh, Ryan, Steve all in one team, but then if Josh is the team leader, Ryan is the goalie, Steve is the attacker, you can mix it up. Ryan could be goalie, etc. So now the order matters, and that's why we've got more options with this. Again, you chuck the formula in your calculator. Final question. 3 games are played. What is the chance of Shirts winning each game? Well, Shirts has a 1 in 2 chance of winning because there's only 2 teams. If we're assuming that they're both equally skilled, all right, maybe in the real world that's not likely, but given a question like this, they would assume that you say there's a 50% chance of them winning. That might not be the case in the real world. Check your sports bet odds, obviously. So 1 in 2 times 1 in 2 times 1 in 2. It's the multiplication principle. You do it, it's 3 times a 1 in 2 chance. 1 in 2 times 1 in 2 times 1 in 2, 3 times 1 in 6. Pascal's triangle. That's Pascal's triangle. Draw it. Draw it in your book. So how does it work? Oh, we got this lot of 1s on the outside. And then what you do is, starting with the 3rd row, you look at the row above it and you add them up. So 1 plus 1 equals 2. All right, now this next row, 1 plus 2 equals 3. Next row, 1 plus 3 equals 4, but also 3 plus 3 equals 6. And you just continue this pattern. Why is that useful? We have we have the binomial theorem, and this is how we're going to use this little Pascal's triangle. This is how Pascal's triangle applies. So consider x plus y raised to the n. So we've got some thing, and it's been factored, and it's been turned from some expanded polynomial into this contracted x plus 5 raised to the 7, whatever. We want to expand it. How are we going to do it? We just use this equation. And how are we going to find each term? Well, we got this combination. And look, each combination maps straight to the binomial, to Pascal's triangle. So consider x plus a squared. Well, the first term is going to be, let's start with k equals 0. Okay, so x raised to the, well in this case, n is 2. So we've got x squared. And okay, 2, 0, what's that? That's 1. All right. Okay, and this is y is 0. So we got x squared. Okay, how about k equals 1? So we've got k equals 1. So then we've got x raised to 2, take 1, so that's x, multiplied by y. So we've got 2 and 1 here. 2 and 1. Oh, that's 2. So we get 2ax. Okay. How about, what about in this case, what if we have y, so k equals 3. All right, k equals 3. We've got n take 3. Well, okay, and then finally, we have k equals 2. So for k equals 2, 2 take 2 equals 0, so x goes away. But y, for this function, of course, it's a, it's not y. So we have a squared. And then we've got 2, so 2, there we go, a squared. Now let's just consider this. So obviously, we don't need to be looking at this equation every time. Maybe if we wanted to find the kth term, we'd have to look at remember the equation just to strike our memory. But come on, we're better than that. Let's say it was x plus a raised to the 4. Well, here's a little trick. Starting from here, this is 0, 1, 2, 3, 4. Well, I want you to guess what x plus a raised to the 4 is. I'm going to tell you. It's x raised to the 4 plus 4 x raised to the 3a plus 6 x squared a squared plus 4 x raised to the 3 plus 4 x a raised to the 3 plus a raised to the 4. You get it? You literally just read this off. Simple. Well, thanks for watching. And the next video is going to sum up my series on statistics. So please definitely watch that. Please make sure you have detailed notes. Do lots of practice questions. Remember, it is easy to rewind these videos. Comment anything you don't understand. I'll be monitoring the comments for a while after the video is posted, and I will probably answer your question. Please, I really hope you're enjoying these videos. Please feel free to reach out. I would just love to get feedback. Thanks heaps.
Hello, hello, hello. Welcome to my video on statistics. So let's go over discrete and continuous data, mean, median, and mode, range plus interquartile range, standard deviation, and normal distribution, as well as random errors. Now, discrete and continuous data. So a discrete variable is a variable in which can only take a value from a set of finite values. A continuous variable is a variable that can take a value from an infinite range of values. Discrete data is countable. For example, the height of students rounded to the nearest millimeter is discrete. However, the actual height is likely to be a continuous data value, e.g. 180.1 millimeters. So what we're looking at here is a discrete value has a set value. So you're saying, okay, we have a set of numbers, 1, 2, 3, 4, 5. It has to be one of these values. So if you're trying to do a height in a discrete value, you'd have to estimate. That could either be 4 meters or 5 meters. That couldn't be 4.5 meters. But if we had a continuous range, well, then you could actually go, all right, well, this person's height is actually 4.5 once it could go forever and ever and ever, just infinitely. Mean. So the mean, what is the mean? This is the average value in a set. And here is the definition. So this is the infinite sum of numbers. So you add up each number in the set. 1 plus 2 plus 3 plus 4 plus 5, right? You're adding up each number, that's xi. And then you divide it by the number of values in the set. And there's an example down there. Median. So in one day, the same 5 centimeter, a 10 centimeter, and an 11 centimeter man walk into that very small bar. What is the median size of a man who entered the bar that day? Well, the solution, you've got 5, 10, and 11. These are the size of the men. But as you can see, the median is the middle value. So it's going to be 10 centimeters. What about the mode? Well, now consider a different situation. Now you've got more men than before. So you've got all these men. You've got a 5 centimeter man, you've got a 6 centimeter man, you've got a 7 centimeter man, and you've got 2 10 centimeter man, 11 centimeter man, and a 12 centimeter man. Because you've got 2 10 centimeter men, that is the most common value. So the mode is the most common value. So 10 is the mode. Range. So the range is the difference between the smallest and the largest value. So if we've got a set of numbers from 1 to 100, then the range is going to be 100 take 1, that's going to be 99. Interquartile range. So what I want you to consider is the numbers. If we take all the numbers and you see, let's say there's 12 numbers. Well, there you could divide that into 4 lots of 3. So you could take off the bottom and the top quarter. So you take off the top 3 and the bottom 3. The interquartile range is the middle 6 values. It is the middle 2 quarters. And that right there is a box plot. So that box plot, you can see in the box, that is the values that we are worried about. That's the interquartile range. And then these values on the side, well, that is the entire range. So we've got the entire range and we've got the interquartile range. And this little red line, that is the mean of our numbers. Standard deviation. All right, so the standard deviation, the definition of standard deviation is this. It's the What I want you to do is you to take a deviation. So a deviation is the difference between 2 points. So let's say if you have the middle and you take any point from that and you subtract it. So what you're fundamentally doing is you're saying how far is each point from the middle? And then what you're going to do is we want to find the standard deviation. So we want to sum up all of these deviations. Now what you do to do that, the problem is that some of these values are going to be negative. So this deviation here is going to be negative and this one's going to be positive. But then we want the middle. We don't want to think of these negative numbers. If something is 5 meters this way from the middle or 5 meters that way from the middle, we just want to say that it's 5 units away from the middle. So we're going to consider negative and positive as the same. Now, the easiest way to consider negative and positive as the same is to square it, right? That's going to get rid of that negative sign. And then you take the square root and that's going to return it to the original value. So negative 5 squared is 25. Square root that, that's 5. Same with 5. So what we end up doing is we do this and we do the sum of all these deviations and then you divide it by the number of deviations and you subtract 1. And that's how you do standard deviation. Now this is a normal distribution. So let's get the function for normal distribution. This right here is the function for normal distribution. Write it down. Most years you won't have to solve a question using that in the exam, but you should know this formula. You're going to treat this formula. You're not going to use it in year 11, but in year 12 you're going to use it. I doubt it would even be in a year 12 exam though, but it might be. And this is how normal distribution works. So the normal distribution is a curve like this. And what you can see is that 68.26% of the value is here in the middle. And then if you go out a bit further, you have 13.59% on both of these sides, and then you've got 2.14. So it's this normally distributed curve where most of the people are in the center. And you can see for each additional standard deviation, you've got these different values. You should draw this because you'll get questions where you'll be told, okay, so 1 standard deviation from the mean, what is the chance of this value happening? Let's say this is 5 and this is 6. They might say, what is the chance of something occurring being greater than 6? Well, if this is 6 here, you can go, oh, it's going to be 13.59 plus 2.14 plus 0.13. Now, what is the normal distribution? The distribution is bell-shaped, symmetrical around the mean. Variation in many quantities can be approximated using a model of normal distribution. When a data set is created of the mean values of repeated trials, the data set of mean values will be normally distributed. So there are many occasions when a data set will follow a normal distribution, but we can know for certain that if a data set is created consisting of the mean values of repeated trials, the data set of mean values will be normally distributed. Okay, what does that mean? We know that when a data set blah, 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 it will be normally distributed. Well, this also teaches us about random error because this means that the effect of random error can be reduced by repeating an experiment a number of times and finding the mean. A mean of a set of means of data sets will have a massively reduced effect of random error. Thank you for watching. That is the statistics portion of this course done. We are up to calculus. Kick ass.